Section 14.3 deals with what are called acid chlorides and acid anhydrides. So far in chapter 14, we've studied carboxylic acids and esters, and now we're going to look at two new exciting functional groups. The first one, the acid chloride, is similar to a carboxylic acid, except you replace the hydroxyl with a chlorine. Okay, you should all be fully aware of a carboxylic acid. So all we do is cross this part out, right? We remove the hydroxyl, replace it with a chlorine, and there we have it, an acid chloride. Now, the first thing we're going to do is we're going to look at the nomenclature of acid chlorides, and the way that you name them. As long as you know how to name a carboxylic acid, you, my friend, can name an acid chloride, because all you have to do is name the analogous carboxylic acid, drop oic acid, and replace it with oil chloride. Let me show you an example. If you had this carboxylic acid, right, CH3C carboxyl like that, this would be ethanoic acid. Well, what you do is you drop oic acid and you replace it with oil chloride, ethanoyl chloride. Now, something that's not shown here in our slides is what you do with common. And I'll show you right now. Is the common name of this molecule would be acetic acid. And what you do is you replace, let me write it up here first. You replace ic acid, okay, with ill chloride. Okay, and you can see that that's what's happening here in this example. We have acetic acid, we remove ic acid, and we replace it with ill chloride, and we get acetyl chloride, or sometimes people pronounce it acetyl, acetyl. Either way is fine with me. So with that in mind, let's look at the next example. If we had a 3-carbon carboxylic acid, right, 1, 2, 3, that would be propanoic acid. We replace oic acid with oil chloride, so we get 3-bromo-propanoyl chloride. If we wanted to give this its common name, it would be propionic acid, so it becomes propionyl chloride. And we have our bromo at the not alpha, but the beta position, so beta bromopropionyl chloride. Let's take a look at the last one too. It's kind of a fun one. If you had a benzoic acid derivative, right, this would be 4-chlorobenzoic acid, so it becomes 4-chlorobenzoyl chloride. And there is no common name for benzoic acid. Okay, that's the IUPAC and the common name, I guess, and so we call it just parabenzoyl chloride. Would work as well. All right, there you go. So that's nomenclature of acid chlorides. Now let's talk about the reactivity of acid chlorides, because it's pretty interesting. So acid chlorides are actually very, very reactive compounds. I worked in a lab where a guy used to take the acetyl chloride. So again, this is acetyl chloride. We had a big bottle of it in the lab, and he used to pour it into the sink, into the water, into the dishpan when nobody was looking, and it would make a sound like it was popping, or it sounded like a gun was going off, and he thought it was the funniest thing ever. I didn't think it was funny, but anyhow, he found it amusing. So did I put a hydroxyl group there when I meant to put a chloro? Yep. All right, I'm getting tired. All right, anyhow, so I wouldn't recommend trying that, but I've seen it done, and it's a pretty stupid thing to do. Anyhow, acid chlorides, it says here, they're noxious, irritating chemicals requiring great care in handling. I don't know how to describe it to you, but I've experienced many acid chlorides. But since they react with water so quickly, I've never been exposed to tear gas in my life, so I can't tell you what it's like, but I'm sure somebody hearing my voice probably has. But if you think about it, since they react with water so violently, and it says it right here, they react violently with water, any place in your body where there's moisture, so in your nasal passages or your eyes, it will start to sting, okay? So that's what it means by noxious and irritating. What else? Acid chlorides are slightly polar with boiling points near the corresponding carbonyls temperature. That means they have boiling points close to the analogous aldehydes, ketones, and now we can throw esters in there as well. Okay, and you can see there is a dipole going this way, and there's a dipole going that way like that. But what acid chlorides are good for is that they're really handy in synthesis as acyl group transfer reagents. Now, if you're wondering what's an acyl group, well, if I go back and draw my acid chloride, okay, this portion here, this is called the acyl portion. Okay, so an acid chloride is very good at putting that acyl group on other molecules. An acid anhydride looks like this. It has this generic formula. It's kind of like as if two carboxylic acids meet on the street. So we'll draw one carboxylic acid like this. We'll add another carboxylic acid facing it. Okay, and what you do is you end up losing H2O. So you end up losing two hydrogens and an oxygen. So you end up with water. But then what's left over is you have RC with an oxygen, and then you have another carbonyl like that. So that's where anhydride, that's where it comes from. It means without water, lacking water. All right, so an acid anhydride is two carboxylic acid molecules with a water molecule removed in the process. Symmetrical anhydrides are ones where the acyl groups are both the same. These are both symmetrical. Okay, both of these down here, because the two acyl portions, this is an acyl portion and this is an acyl portion. They're identical. This is an acyl portion. This is an acyl portion. They're both identical. And when we name those, we just name the carboxylic acid and we slap the word anhydride on the end, right? So if you had a 2-carbon carboxylic acid, right? If you had this carboxylic acid, you would call that ethanoic acid. So you'd call this ethanoic anhydride. The common name is acetic acid, so you call it acetic anhydride. Similarly, if you had this carboxylic acid, and I know that you know where I'm going with this, you would have benzoic acid. And so if you have two of these acyl portions, it becomes benzoic anhydride. All right, so a couple new functional groups, the acid chloride and the acid anhydride. Here again is a reaction showing the formation of an acid anhydride, which I drew on the previous slide. Okay, so you have the two carboxylic acids. They're both pointing towards each other, and you don't have to draw them pointing towards each other, but I find it just kind of helpful. What are you going to lose? You're going to lose H2O. So you lose water, and then you end up making a new bond between this oxygen and this carbon right here, and there you have it, your acid anhydride. Give me a thumbs up if you follow me on that reaction, the formation of an acid anhydride. All right, wonderful. Thanks, Ryan. Good. All right, well, let's move on from there. What else can we do? It says here that we can bring these two concepts, acid chloride and acid anhydride, together. And it says here that we can actually use an acid chloride to make an acid anhydride. So it says here, one reaction used to form acid anhydrides is the combination of an acid chloride with a carboxylate anion. That reaction is shown right here in this green box. If we take an acid chloride and we react it with a carboxylate, we end up producing a carboxylate. Sorry, we end up producing an acid anhydride, and we also release a chloride. If you have a hard time memorizing this reaction in this green box, let me just show you what actually happens. Is that since there's two dipoles on the carbon of the acid chloride, right, that's going to render this carbon really partially positive. I'm going to delete those two dipole arrows. Now, if we have a partial positive charge here and we have a negative charge here, what do we know about positive and negative charges? They attract each other. And so I like to do this. I like to say, well, I'm going to connect between the negative and the positive. Now remember, carbon can't have 5 bonds. And this arrow that I've drawn here, that represents the formation of a new bond. So that means that I'm going to have to lose the chlorine. So I'll draw an arrow like that. And that helps me remember that my red arrow formed that bond. Okay, and now I end up with a chloride ion. Now you might be wondering, how would I make an acid chloride? Okay, and I think this will be the last reaction that we'll look at tonight, is if you take the analogous carboxylic acid and you treat it with SOCl2, you end up with the acid chloride. And the name of SOCl2, I'll put it up here, SOCl2 is called thionyl chloride. So take a carboxylic acid, treat it with thionyl chloride, get the acid chloride, then you can react that with a carboxylate and make an anhydride. Pretty neat, huh? Very interesting chemistry. All right. The types of acid anhydride reactions with alcohols. It says here that you can react an acid anhydride with an alcohol to produce an ester carboxylic acid, and this is an acyl group transfer reaction.